Hey guys, welcome back. Unit 11, day 4, we're going to do some modeling with polynomial functions and solving graphically. So obviously here you're going to need your graphing calculator. All right, first example, engineers designing a roller coaster. All right, and we're given this particular function, h of x. And what does that mean? Well, it says h of x is the height of the roller coaster in yards. All right, so it's important to know that. And then this is a little bit confusing, but it says when the roller coaster is 100x yards from the beginning of the ride. So basically that means if we have a coordinate of x equals 1, that really represents 100 yards. X equals 2, 200, so on and so forth. And we also need to know we're graphing it only for the first 300 yards. So what I'd like you guys to do is I'd like you to throw that function into your calculator. I've already done it. And let's think about the window we would like for this particular function. I kind of want it to match what I see here on my grid. So you can see here our x values. Really we only need to go to 3, but I'm going to go to 4 just to kind of make it look like this window here. And our y max is going to be 10. So let's say graph. All right, so what do we know? Well, it goes through the origin. Looks like it has a root at 2 and a root at 3. And before I sketch this in, I actually want to find that relative maximum, that first relative maximum. So let's do this real quick. Second, calc, maximum. And I'm going to move it over here to the left of that relative maximum to get the left bound. Just get it close, hit enter, move it to the right of that. Hit enter, and then move it back. Guess, hit enter. So I want to go out 3 places here. All right, so that coordinate would be 0.557, comma 8.50. All right, so roughly 0.6, just kind of estimate it, and then about 8.5. So 1, 2, 3, 4, 5, 6, 7, 8.5, kind of right in this vicinity. So a little bit challenging with my scale here. It goes up pretty steep, turns around. That's not the greatest, but it'll do. Comes up and down. Okay, so I'm going to cheat a little bit here. Okay, so there's my function. Graph h of x. Great, got it. Now it says for part B, at which distance from the beginning of the ride is the coaster at its lowest point? So it's going to be at its lowest point here and here. Now if you remember, that's 1, 2, and 3, but that's really like in hundreds of yards. So at 2, from the beginning of the ride, it's going to be at 200 yards and at 300 yards, lowest point. Okay, for part C, I want to find to the nearest 100th foot, so that's a little bit different. We're talking about yards. The maximum height the coaster reaches. So the relative max right here of the coaster is 8.50. So what we need to do is we need to take 8.50 times 3, because obviously there's 3 feet in every yard, and that's going to give me a value of 25.50 feet to the nearest 100th. Okay, moving on. When will the coaster reach a height of 4 yards? So what we need to do here is we're going to have to find some intersection points. So we're going to go to y equals, and in y equals 2, let's put in 4. Take a look at your picture. So on my graph, basically 1, 2, 3, 4, I want to find the intersection with this. It's going to be 2 points, P1 and P2. So now I can use my intersect function. Second, calc, intersect. And first curve, I'm just going to go over here. I like to go left to right. You don't certainly have to. Okay, whoa. Here we go. So let's see, what do we want to round to? Doesn't specify. I'm going to go 10th here. Sorry for moving all that around. So P1 is going to be actually, let's go 1,000. 0.134, comma 4. And then second calc intersect again. All right, enter, 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 and 1.2164. When will the coaster reach a height of 4 yards? So if you remember, this is in hundreds of yards. So it's going to reach a height of 4 yards at 2 locations, but I have to multiply those by 100. So I'm going to say at 13.4 yards and at 121.6 yards. Okay, and finally here it says a bird's distance from the ground can be modeled by b of x equals negative 1.7x plus 8. At what distance from the beginning of the ride will the bird hit the coaster while the coaster is going down, round to the nearest yard? Okay, so what we're going to do here is we are going to put that function now into y2. So let me clear this one out. Negative 1.7x plus 8. And let's take a look at the graph. Now notice it intersects twice, but it clearly says when the coaster is going down. So let me sketch this in. So I'm just call that y3. So I only need this point right here. I'm going to call that p3, okay, because that's where the coaster is going down. So second calc intersect, and I need to get up towards that point of intersection. Just get it close, enter, enter, enter. So again, let's go nearest thousandth for this point of intersection. So I'll call this P3, 0.958 and 6.371. So how are we going to interpret that point? At what distance from the beginning? So that's going to be your x value. It says round to the nearest yard. So again, remember our x values are in hundreds of yards. So I'm going to take 0.958, multiply that by 100, and that's going to be 95.8. It says round to the nearest yard. That's going to be 96 yards. Okay, let's move on to the next page. This is a great example right here. A piece of cardboard is 13 inches by 20 inches. So we've got a piece of cardboard here. That's 20 inches. And that's 13 inches. A square of length x is cut out of each corner, and the sides are folded up to create a box. So we've got something that sort of looks like this. And I know that dimension is x, because we're cutting out the squares, then we're folding the sides up. So it says state the dimensions of the box in terms of x. So if you think about it, this edge of the box right here is this length right there. Now that's not 13. The whole width is 13. This edge of the box right there is that length. So if each of these ends are x, basically I want to write this dimension here as 20 minus 2x. And this dimension here is going to be 13 minus 2x. Okay? So this is 13 minus 2x. And this is 20 minus 2x. So state the dimensions of the box. All right, so you can say length, 20 minus 2x. You can say width, 13 minus 2x. And you can say height is x. Now in part B it says write an equation to find the volume of the box. Going back to geometry, volume equals length times width times height. So our volume is going to equal x times 13 minus 2x times 20 minus 2x. All right, you don't need to multiply that out, but this is the equation to find the volume. Okay, so now we need to make a sketch. I've already loaded this into the calculator. So you're going to put the volume equation into your calculator, just the way you see it. Like I said, you don't need to multiply it out. Factored form is fine. And for the sake of brevity here, I've already adjusted my window. So you can take a look at what I put in. I played around with it a little bit so I could get a semi-decent graph. That's what I've got for my graph. So we're going to make a quick sketch. I want to talk about the appropriate domain for this. Okay. So there's my sketch. Now what I need to do is I need to label some pieces here. All right, so I want to find my roots. Now if you notice here, I doubt they are nice integer coordinates, so I'm going to go to y equals, and I'm going to put in a 0 for y2. Now I'm going to do second calc intersect. And I'm just going to give this root here. So 6.50. And the other one, second calc intersect. $10,0. And I also know it goes through the origin. So the next question is kind of interesting. It says, what is an appropriate domain for the length of the square x? Explain. Now a couple things here, if you remember, is that this function represents the volume. So I think it's pretty obvious that volume can't be negative. So any part of the graph that dips down below the x-axis would give you a negative volume, and therefore it's not possible. Now the other thing we need to take into consideration is that x is what you're cutting out of this box. So if you think about this side here, 13 minus 2x. Now if I'm looking at the graph where it is above 10, you might think, oh, well that's perfectly fine. That volume's positive, so why can't I just use that? Well, if x is 10, 13 minus 2 times 10 is going to give you a negative 7. We can't have a negative length. So even though this volume is positive, I can't use it because it would give me a negative length. Anything beyond 6.5 for x will yield a negative number, or 0, and you can't have 0. So an appropriate domain for the length of the square x would be something like this. 0 is less than x is less than 6.5. Because all other values would yield a negative volume or dimension. And we can't have a negative either. Okay, moving on. It says find the maximum volume of the box and the size that should be cut from each corner to maximize to the nearest hundredth. So obviously I need to find that relative maximum. So we'll go back to our calculator, second calc maximum, hit 4, and I move my cursor over here. Enter, right bound, enter, and back, enter. So it says here 2.57 and 300.17. All right, so find the maximum volume of the box. That maximum volume is going to be 300.17, and the size of the square you have to cut out would be 2.57 inches. Okay, so we're going to take a little break here. There's one more part of this lesson that we need to go over, but I'm going to do a separate video for that. Thank you.